This video is the first on this subject and is about the promise of finding an RCB when doing the proposed research. The acronym RCB does not mean anything to you yet. For the first time in history, we may have a complete machinery description for reality, for nature. We go beyond the symmetries and other exhibits that we can experience with the scientific method. The scientific method is the method that is constructed by the most elementary of human divisions into measuring apparatus and the rest. This is about the ultimate step we can make as humans to go beyond our human perspective, or, as I have often said, to go beyond the scientific method, which in my opinion is the same thing. Until now, as I have sometimes argued, we have overestimated our ability to describe the world with mathematics and physics. I repeat, we have overestimated our ability to describe the world with mathematics and physics. The very foundation of mathematics we thought was healthy has flaws in it because of improper definitions and an improper axiom. The best way to fix these flaws is to admit to our inability to define continuity and infinity by introducing a new object into mathematics. For lack of a better word, I called this confession of inability an in-between, but the name is of course open for debate. An in-between is a continuous object and only partially accessible with numbers. With this object, the in-between, we can describe an object called SpaceTimeCapital. This continuous object SpaceTimeCapital is only partially accessible with numbers, but that is all we have, and I think that suffices. We should not mix the real limitations of discreteness with the a priori wrongly inferred discreteness of reality itself. This is not to say that reality cannot be discrete, but it shouldn't be discrete because our means of describing are discrete. I personally believe reality to be continuous is more likely than it to be discrete. No one has yet presented hard evidence for either of them. Some seem to claim to, but they cannot show me consistent definitions for continuity and infinity. This is not going to hold us back anyway. What is really holding us back is that it could be true that reality is one single object, while the scientific method is destined to be a two-object method, as part of human reality, namely measuring apparatus versus the rest. The scientific method is destined and doomed to distinguish, yet conjectured, reality has no distinction in it. It's one object with properties. I propose in this video to examine this one single object and see if it can enact all the properties we see from our scientific perspective. If it can enact what we see, that would explain so much more than we can now explain with only the scientific method. Here we go. Capital letters are sometimes meaningful in words. I will speak of SpaceTimeCapital, space capital and time capital to distinguish from Einstein's spacetime, space and time. SpaceTimeCapital is introduced as a four-dimensional in-between with properties. 1 dimension for time capital and 3 for space capital. This is essential because spacetime, space and time are to be inferred from SpaceTimeCapital, space capital and time capital when introducing perspectives, like the two-object division perspective from the scientific method. we will sample the in-between, SpaceTimeCapital, with numbers, and we will introduce points as concepts that are the result of sampling. A point is a combination of 4 numbers, like when we sample Euclidean space. The difference between points, as we know them from mathematics, and the special points or touching points when sampling in-betweens is discussed in an earlier video. Also see the book in the description below. Suffice it to say, you can think of touching points as normal points, and nothing will go wrong. Nothing would even go wrong using mathematics with infinities, because we wouldn't be using infinities anyway, as we have never done, and the computer never will. We just wouldn't strictly be speaking of a 4-dimensional continuum. In mathematics we have to be precise, beyond the point of everyday conversation. So if as a philosopher you have some delicate questions, go back to the proper definitions. SpaceTimeCapital is diffeomorphic to Euclidean space in mathematical terms. In layman terms, this means that by smooth transformations, by smooth distortions, one can become the other. We are ultimately looking for fermionic behaviour in SpaceTimeCapital. That is our quest for now. We can do this in the 21st century with the help of artificial pattern recognizers, or AIs as we unjustifiably call them now. We want to deform SpaceTimeCapital in such a way that it shows us all the behavior we recognize as photons and electrons and the Standard Model and general relativity and quantum mechanics. Fermions are the most elusive, and photons are mathematically already shown to be part of the story by Pierre Millet. A reference from his book is in the description below. My objections to his model for fermions are stated in my book in the descriptions below. Conceptually, it should be possible to generalize to the rest of the Standard Model, but that is part of our continuing story in this new world of physics. So the existence of a resonance carrier Ball topology, or RCB, I repeat, a resonance carrier Ball, RCB, is needed to allow for fermionic behavior in SpaceTimeCapital. I conjecture that we need an extra conceptual layer for our simple elastic in-between that constitutes of shapes that resemble topologies of a different nature than Euclidean space. We need look-alike balls, we need RCBs. I suspect that will suffice to create toruses as well. I suspect look-alike is good enough. The topology of an exact ball cannot be reconstructed or constructed in the simple topology called SpaceTimeCapital. We need symmetry breaking to establish lookalikes, and this is not an odd thing to happen, as we recognize the concept of symmetry breaking from our experiments with the scientific method. We need symmetry breaking in SpaceTimeCapital reality to explain symmetry breaking in human perspective reality. The extra conceptual layer is there on paper to facilitate resonances of the elastic material that is SpaceTimeCapital. I imagine these RCBs, diffeomorphic to Euclidean space, to be stable configurations and capable of carrying resonances of interacting frequencies. The research is there to create RCBs in the computer and fill them with resonances and make them move, just by letting SpaceTimeCapital move as an elastic piece of material in the computer, to do its thing as an elastic single fabric. When invoking a perspective and recognizing local particle shapes, we introduce the scientific method and look for confirmation of local behavior as particles emerging from SpaceTimeCapital. We look for inferred fields descriptions to show quantum mechanical behavior, we look for large-scale structure to show gravitational behavior. This is all difficult. So again, this simple elastic space, called SpaceTimeCapital, is at first sight not capable of exhibiting fermionic behavior. We need to present a layer between the structure of SpaceTimeCapital and the material structure for fermions. This layer should be diffeomorphic to SpaceTimeCapital and at the same time facilitate or mimic a structure that is fundamentally not diffeomorphic to SpaceTimeCapital. The RCB is that layer, that structure mimicking a ball, different theoretically in only one point and different practically in a small volume. The RCB, the resonance carrier ball, is the structure upon which resonances can, will and must develop. The RCB and resonances as an ensemble behave as a fermion. The requirement for an RCB to exist and be stable is necessary for the whole story to have a chance to describe nature. If we can find RCB and resonances, it would, in my opinion, be the first time in physics that we have complete machinery and a material description for reality. If we can exclude the RCB from existence, which would surprise me, this story just isn't the story. That would also be a very important result. There seems no excuse for not doing the research. The costs will be in the order of 10 million euros. Numerical experiments should precede algebraic research, I suspect. We should start numerical experiments and will perhaps, as a result, find more algebraic descriptions. Let's get lucky. Guided luck.